So yesterday's sine, cosine, tangent, those were the ones we knew about before. And then we also talked about secant, cosecant, and cotangent. Those are not as necessary because they're just the reciprocals of sine, cosine, and tangent. In addition, many calculators, they don't have a secant, cosecant, cotangent button. They have sine, cosine, and tangent. So, but I just wanted you to be familiar or at least have heard of those before. They're just reciprocals of the other ones. Today we're going to use those functions, sine, cosine, and tangent, to solve right triangles. And when you solve a right triangle, it means to do this. It means solve the triangle means find all the angles, find all the sides. One quick thing about how they're labeled. So this is triangle ABC, like this, right? You list the vertices, ABC. Remember that angle A across or opposite from angle A is side A. Remember that? If this is angle B, across from angle B would be side B. Angle C, opposite side C, which happens to be the hypotenuse. So in this particular problem, they tell us angle A is 36, so I can write that one down. And they tell us side B is 50. We have to find everything else. Well, they sort of give us one other angle, right? If that's a right angle, even though they don't say it, we can assume it's 90 degrees. And then shouldn't you be able to find angle B if you know those two? 180 minus 46, 56, 66, 76, 86. Is that 54? So you got all the angles. Now we need to find the sides. If I knew one more side, I could use the Pythagorean theorem. You could use the Pythagorean theorem, right? So we need to find one more side. And to do that, we're going to use sine, cosine, or tangent. Just a side note here before we try to. If you're asked to find something, and you can either use information they gave you or information that you calculated, which do you think is more reliable? The given, right? So if it's a choice between using given information and using stuff that you calculated, I would choose the given information. If you make one little mistake and then you use that to find all the rest, everything's going to be wrong. So over here, I would go with angle A because they gave us angle A. And I would label my sides according to angle A. See this one over here? That's the opposite. The one next to it is the adjacent. The hypotenuse doesn't really matter so much. So I'm going to use angle A. If I wanted to use angle B, could I? I can use whatever angle I want. If I want to use angle B, though, then when I label it, this is going to be my opposite, and over here will be adjacent. You just have to label it as according to what angle you're using. So, if I use angle A, for angle A, opposite, and 50 is the adjacent. What function do you think I should use if I'm looking for opposite and I want to find adjacent. What function would that be?
Tangent.
Tangent. So the tangent of any angle is opposite over adjacent. Well, in this case, what's the angle that I'm looking at? 36 degrees. Tangent of 36 equals, what's the side opposite? A. What's the side adjacent? 50. And so now we're just going to work that out. In order to work it out, the first thing I'm going to have to do over here is figure out what is the tangent of 36. Get your calculator, 36 tangent. You might want to work it along with me. Like that. Here's the tangent of 36. I wouldn't round it till the very end. The sooner you round in a problem, the farther off your final answer is going to be. How would you solve this now? I think I'd put a 1 under there and cross multiply. A times 1, and then you're going to take that 0.7265 and all those, times it by 50. You get 36.3-ish. Now that we're at the end, you can round. So side A, 36.3. Now we need to find the hypotenuse. If you want, you could use adjacent over hypotenuse. You could use cosine to find the hypotenuse. You know what I'd rather though? Once you know two sides, you know what I prefer?
Pythagorean.
Pythagorean. So what's A? 36.3 squared. What's B? 50 squared equals C squared. You can get it from there, right? Does that make sense? Does that make sense? At least the two people. I think the rest are sleeping. So how about this one now? The difference with this one, I know two sides. I know side A is 5, side B is 12. I also know angle C is 90. Anybody with suggestions? The easiest thing would be to find the third side, I think, right? Right off the bat. So A squared plus B squared equals C squared. A is 5, B is 12, and I need to find C. What is that?
25 is 144, 169, which is 13.
Wait, you're going too fast. I can't write that fast. 25 and 144 is 169, he says.
Yeah.
Square root, square root. So I get side C is 13. Is that what you get?
Sure.
Does that seem reasonable? Bless you. Remember, the hypotenuse always has to be the biggest side. Is it?
Yeah.
Yeah. Seems reasonable. Oh boy. Now we need to find one of those other angles. Uh-oh. Now I need to find one of the other angles. I like to start with this one down here. I don't know why. This one up here seems way up there. So what are we going to do? We're going to label the sides according to this angle. What's this one? Right, it's the opposite. So that means this one down here is going to be, and obviously always, no matter which angle, across from the right angle is the hypotenuse. So remember, we should probably use the given information if we can. And we were given these two sides. I was given this one, the opposite. I was given this one, the adjacent. What function do we happen to be using again? Tangent, right? Opposite and adjacent, that's tangent. So here's what we're going to do. Tangent theta, opposite over adjacent. Now this time, it's different because I don't know what that theta is, right? That's what I'm going to be looking for. What? That's what I'm going to be needing to find. I think I need to go home. What's the opposite side? What's the adjacent side?
12.
So that's what we have so far. Now we need to figure out what that is. Here's where I would start, right here with this. 5 divided by 12. Ooh, I know what that is because I did it twice already today.
A couple.
Do it on your calculator.
Calculator's broke.
What do you get? 6, 6, 6, 6. How many of those should I put?
As many as possible.
Darius says as many as possible.
Keep going.
I don't want you to cut that off. I don't want you to cut that off. Darius says I should keep going. I don't want you to round that. I want you to keep going. I want you to keep going. How many will fit on your screen?
Just wrap it around the room.
6.
I think I need to go home.
Come on, Miss May.
Hey, if I keep going, I'll be right out the door.
Miss May, you're like devil times like 24 right there.
Yeah.
Yeah?
27 now.
Yes. You know what I did one time? I kept going, and I'm facing a moral dilemma now, because if I keep going onto the wall, it's not going to come off.
Keep going.
Do it.
Do it.
Do it. Do it. Do it. Do it.
Do it.
Do it. You won't.
Yeah.
Oh, I have to quit at 1.
No.
I know it's on video.
You can just get rid of it.
I can't even say one of the kids did it.
That was Chloe.
The camera's going out.
Yeah, it was definitely
Yeah,
Chloe.
it's Chloe.
Well, my point is, I don't want you rounding this. The sooner you round in a problem, the farther off your answer's gonna be no.
I try to pull it.
I don't want blood on my carpet.
There is a beat.
Shh.
So,
So, look up here. One last thing. Look. I want to know what angle has a tangent of 0.416 repeating forever. So on your calculator, you're going to have to use the shift tangent or the inverse. Remember when we did inverse down there of a function, that little -1 means inverse. So type in this, inverse tangent. Wait, I gotta get it, 0.41. It's gonna take me a while to type these 6's in forever. Mine I shift. So shift or second, and I get something like this. Theta equals 22.6.
Miss May, my calculator is broke.
Now, one thing though, somebody last hour or the hour before, their calculator wasn't in degrees. So no matter, even if they typed it in right, they still didn't get the right answer because they weren't in degrees. So you want to make sure you're in degrees. What angle is that? Oh, I forgot to put A in here. I'm going home. That's angle A. That's angle A. 22.6. And then you should be able to get angle B after that, right? 32, 42, 52, 62, 72, 82, 67.4 maybe? Right? 180 minus. Can everybody get this? Were you able to type this in and then the inverse tangent? Yes? Does it make sense? And remember, if you wanted to use angle B as your angle, you could do that. If you want to use angle B, though, up here, then this is going to be your opposite, and this one is going to be your adjacent. Exactly opposite is if you used angle A, right? Make sense? Make sense? Do you have questions? Are there any questions? Does anyone have a question? That'd be page 577. Page 577. WE 1 to 58.